Hello students, today we are going to see NCERT section 8.4, 8.4.2 and some related examples. This will be mainly covering the theory part. A small disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is an experimental. Thank you. So in today's session, we are going to cover geometric progression, in short GP, its definition, some related examples, its concept. Then we are going to see the general term of a GP. Then sum of n terms of a GP formula. And then examples from 4 to 11. Starting with the definition of GP. So a sequence A1, A2, A3 till AN to infinity. So recall what is your sequence? Simply a list of things, objects, members, simple. This A1 represents first term of your sequence, A2 represents second term and AN represents nth position term. Now if you are having a sequence like this, it is said to be geometric progression if the each term is non-zero. First of all, we want our terms to be non-zero, and the common ratio AK plus 1 by AK must be some R, some fixed number R. Meaning, if you pick any two consecutive terms, say A2, A3, now just divide the successor by its predecessor, and if you are getting some constant number R each time, then your sequence is going to be geometric progression or geometric sequence. Simple. By letting A1 A, meaning our first term is simply A, some A, then you can easily construct a geometric progression. How? Quite simple. According to the definition, what you want? Simply AK plus 1 by AK will be some constant R. So if first term is A, so the next term is going to be AR. Next AR square and so on. Yes, satisfying the condition. Each time you are getting the quotient as some constant R. This R is called as the common ratio of your GP. Simple. I hope the definition is clear to all. Now, notation. We shall use the following notations. So A will represent the first term, R represents the common ratio, L represents the last term if you are having a finite sequence, finite progression, N will represent your number of terms if you are having finite number of terms, or position of your term, and Sn, we are going to use this Sn for sum. This represents the sum of first n terms. I hope these notations are all clear. Moving to next. Now, general term of a GP. Consider a GP with a non-zero term, say A, and a common ratio R. You can easily construct your GP sequence. Now, write few terms. So, how you are getting your terms? Simply, first term is A, second term is simply multiply first term with R. You will get your second term A2 as AR. Also verify or observe that A2 divided by A1 is simply the constant R. Similarly, for third term is simply given by A2 times R. So A3 represents your third term, which is A2 times R, meaning AR square. If you divide A3 by A2, you will get the constant term, this R. Simple. How you are going to generalize your terms? Quite simple. If AN is your some term, then your term will be first term times R raised to the power n minus 1. Simple. Generalization of your term, nth position. Now, a GP can be written as A first term, AR second term, AR square third term, AR cube fourth term, AR raised by n minus 1 nth term. Yes. Now, here you are having n terms, and in this case AR square, AR raised by n minus 1, and these three dots represents that terms are going on. So according to GP, we say the first one is finite and second one is infinite. In first we are having n terms, which is some finite number of terms. In second we are having infinite number of terms, so infinite GP. I hope these two terminologies are clear. Now, their corresponding series is simply represented by A plus AR square till AR raised by n minus 1. This is your finite geometric series, and A plus AR square plus A till AR raised power n plus so on, and this is infinite geometric series. Here we are adding infinite terms, and infinite we are adding finite number of terms. Simple. Now, the nth term of your GP is simply given by A raised to the power n minus 1, represented by AN, where A represents your first term of your GP and R represents your common ratio. Simple. Now, sum to n terms. Let us denote Sn, the sum of first n terms of your GP. Meaning, mathematical way to represent Sn is simply A first term plus second term AR plus third term AR square till A R raised by n minus 1. Why? Because this is your nth term. So, sum of first n terms simply represented by Sn. Case 1. Suppose you are having your R as 1, meaning common ratio 1. So, your sum for first n terms is going to be n times A. This is only going to happen when you have R as 1. Now, for second case, suppose R is not 1. Now, what we are going to do? Now, We multiply r to both sides. We get r times Sn to the left and ar plus ar square plus ar cube till ar raised to power n to the right hand side. We are naming this equation as 2. Now, from 1 and 2, on subtracting, what you will get is, to the left hand side you will get 1 minus r times Sn, and to the right hand side you will get a minus a raised to power n, as all other terms going to be cancelled. Now, taking a common from the right terms, we are getting a times 1 minus r raised to power n. So Sn is simply a times 1 minus r raised to power n divided by 1 minus r, or Sn is equals to a times r raised to power n minus 1 divided by r minus 1. So sum of first n terms of your GP is simply represented by this expression or given by this formula, where a represents your first term of your GP, r represents your common ratio. Simple. This is going to be used when r is less than 1, and this is going to be used when r is greater than 1. And for r1, you will use this form. I hope that derivation of your formula is clear. Moving to next. Now, examples. So, find 10th term and nth term of your GP. So, sequence given to us 5, 25, 125 and so on, following the same pattern. As we are already provided with that the given sequence is GP. So, solution. So, first term is 5, and to get your common ratio, just divide 25 by 5 or 125 by 25. You'll get your GP, common ratio of your GP. In this case, we are getting r as 5. Now, using the general nth term formula, we'll get A10 as first term times common ratio raised to the power 10 minus 1. In this case, we are getting 5 times 5 raised to power n, which is 5 raised to power 10. So, this is your 10th term of your GP. Simple. Now, for nth term, quite simple. Use the same relation. First term times common ratio raised to power n minus 1. In this case, a is 5, r is also 5. So, we are getting nth position term as 5 raised to the power n. Using this relation, you will get your nth position term of your GP. Simple. I hope this is quite easy to understand. Now, moving to next. This example. GP is given to you. Few terms are 2, 8, 32 up to n. So, we are having some finite terms in our GP, and we are provided with a number 1,31,072. We have to answer that which term of your GP is 1,31,072. Solution. Let 1,31,072 be some nth position term of your given GP. Now, what we are given with is the first term of your GP, which is 2. So, A is 2. Now, what is your common ratio? if you are having your GP, you must have your common ratio. In this case, R is 4. How? Just divide 8 by 2, or just divide 32 by its predecessor. Simple. 8. You will get R as 4. Therefore, using the nth term formula relation, an is simply a times first term times common ratio raised by n minus 1. Here we assume that this is some nth position term. So 1,31,072 is going to be equals to 2 times 4 raised by n minus 1. Just divide by 2 to both sides, will get, our equation becomes 65,536, which equals to 4 raised by n minus 1. Now what we are trying to do is writing this 65,536 in terms of 4, meaning just try to factorize it, and we can write 4 raised to power 8. So my equation becomes 4 raised to power 8 is equals to 4 raised by n minus 1. Now this is equal when the both exponents are equal. So 8 must be equals to n minus 1. In this case, just solve for n, you will get n value as n, 9. Hence, 1,31,072 is the 9th position or 9th term of the given GP. Simple approach. I hope everything is clear. Moving to next. This example. In a GP, third term is 24, sixth term is 192. Then we have to find out the 10th term. Quite simple question. Solution. As given, third term is 24. Using nth term formula, we'll get A3, which represents the third term, is first term multiply common ratio raised to power 2, which is equals to 24, already given to us. So A R square is 24. Applying nth term formula here, A6 will be equals to first term times common ratio raised to power 5. So A times R raised to power 5, which is 192, already given to us. Now just divide second by 1 in order to get the R value. So A6 by A3, A will be cancelled. What we are having? Simply R cube, which is equals to 8. Simple. So R cube is 8, meaning R value is 2. So common ratio is going to be 2. Now, in order to get, so we are having R as 2. Now in order to get A value, just substitute R value either in the equation 1 or in equation 2. So we are using equation 1 in order to get A value. So R is 2. So A times 4 is equals to 24, which gives me A value as 6. Hence, using nth term formula, we will get our A10 term. So A10 is going to be first term 6 times common ratio raised to power n. So 2 raised to power 9, which gives me 3072 as my 10th term. Simple. Moving to next. This example. We have to find out the sum of the first n terms. The sum of the first 5 terms. So we have to find two things. Sum of first n terms and first 5 terms. Of what? Of your GP, geometric progression series. Here series is 1 plus 2 by 3 plus 4 by 9. So you all know the geometric series comes from geometric progression, meaning each term here represents geometric progression terms. Meaning you can get your A, your first term, as well as your common ratio of your GP in order to get the idea for next terms. So solution. Here the first term is 1. Now in order to get your common ratio R, you have to just divide this 2 by 3 by 1. So dividing 2 by 3 by 1, you will get your common ratio as 2 by 3. So this constant number is going to be your common ratio of your given GP. Now we are having A and R. We have also derived formula for n terms, sum of first n terms. Just use that. So using the formula, sum of first n terms Sn is equals to A times 1 minus R raised to power n divided by 1 minus R. A represents the first term of your GP, R represents the common ratio of your GP. If you are having R less than 1, we are going to use this formula. Here 2 by 3, indeed less than 1. Now just substitute A and R values. So 1 minus 2 by 3 raised to power n divided by 1 minus 2 by 3. On simplifying, we are getting Sn as 3 times 1 minus 2 by 3 raised to power n. Now this is your sum of first n terms. Now what about for first 5 terms? Just put n as 5. So as 5 represents your sum of first 5 terms, which is, just substitute 5 in place of n. You will get 3 times 1 minus 2 by 3 raised to power 5. This is going to 3 times 211 divided by 243. On simplifying, you will get 211 by 81 as your sum of first 5 terms. I hope the explanation is clear. Moving to next. This example. How many terms of your GP 3, 3 by 2, 3 by 4 are needed to give the sum of 3069 divided by 512. So we want to know the number of terms we must need in order to get the sum of this number 3069 divided by 512. Solution. Suppose n number of terms are needed, and from this information I can say that the first term of my GP is 3 and the common ratio is half, which is indeed less than 1. And what I want is, I am assuming that, say there are n number of terms needed such that the Sn is 3069 divided by 512. Now I am having this much of information. What I can use, I know the formula of first n terms, sum of first n terms in my GP. So using the sum of first n terms, which is first term multiply with 1 minus R raised to power n divided by 1 minus R, where A represents your first term, R represents your common ratio. In this case, A is 3, R is half. So left hand side is simply 3069 divided by 512 and right hand side becomes 3 times 1 minus 1 by 2 raised to power n divided by 1 minus half, which is going to be, so this right hand side becomes 6 times 1 minus 1 by 2 raised to power n. Now on further simplifying, on cross multiplication, we are getting left hand side as 3069 divided by 3072 is equals to 1 minus 1 by 2 raised to power n. Transferring this 1 by 2 raised to power n to the left hand side and this term to the right hand side, we are getting 1 by 2 raised to power n is equals to 1 minus 3069 divided by 3072. On simplifying the right hand side, we are getting 3 by 3072. We can easily simplify the fraction, and we are getting the simplified fraction as 1 by 1024. Now, just try to write this denominator in terms of 2 exponent. So we are getting, this is nothing but 2 raised to power 10. Now on comparing, you can compare easily. You will get n value as 10. So you are going to need 10 terms of your GP in order to get the sum as 3069 divided by 512. Simple. I hope this explanation is clear. Moving to next. This example. So sum of first 3 terms of your GP is simply 13 by 12 and the product is -1. You have to find out the common ratio and the 3 terms of your GP. Solution. We are assuming A by R, A and AR to be first 3 terms of my GP. First of all, verify, are these 3 terms forming GP? Yes. How? In order to say a sequence is GP, first of all, we require that all the terms must be non-zero. Yes, we are assuming that they are non-zero. And we must have some constant common ratio. So if you divide A by this number, you will get what as your common ratio? R. If you divide this term by the second term, you will get still your common ratio as R. So you are having your common ratio constant. So indeed these 3 terms forming your GP. Clear? And always remember that if question says or question includes about 3 terms of your GP, then always assume 3 terms in this form: A by R, A, AR. This will make things easier. Now, according to the condition, the sum of first 3 terms is 13 by 12. So sum A by R plus A is going to be 13 by 12. I am naming this equation as 1. Now the product is -1. So product of all these 3 terms is -1. A by R times A plus A by R times A times AR, which is -1. I am naming this equation as 2. Now from second, observe R can be easily cancelled. You only left with A. So A cube is -1. Now just solve for A. So one value, you can easily say that if A is -1, then this is going to be satisfied. So one solution is -1. We are considering only real values. Simple. Now we have our A value -1. Now substitute A -1 in any of the equation. So we are using equation 1. We have -1 by R -1 minus R is equals to 13 by 12. Just cross multiply and transfer all the terms to the left hand side. We are getting quadratic equation in terms of R. 12R square plus 25R plus 12 is equals to 0. Simple. Now just solve for R. So this is your quadratic equation in terms of R. You can easily solve it by using the quadratic formula. So you will get 2 values for R. One is -3 by 4, another one is -4 by 3. Simple. Thus, the 3 terms of your GP, when R is -3 by 4, so 4 by 3, -1, 3 by 4. If you consider R -4 by 3, then your first 3 terms are 3 by 4, minus 1, 4 by 3. Simple. I hope these steps are all clear to you. Moving to next. This example, quite interesting example. Sequence is given to you 7, 77, 777, 7777 and so on. The other terms follows the same pattern up to n terms. So at nth term you will have how many sevens? N sevens. So you are given with this sequence and you have to find out the sum. So how you are going to do that? Quite simple. This is not your GP, but you can make this sequence into GP. So solution. This is not GP, but however we can relate it to a GP by writing the terms as, so what we want is sum of first n terms. So Sn is simply 7 plus 77 plus 777 plus 4 sevens and so on till n terms. So what we are doing is taking 7 by 9 common. Now we are having right hand side as 7 by 9 times 9 plus 99 plus 999 plus 9999 and so on up to n terms. Now this 9 can be rewritten in this form 100 minus 1, sorry 10 minus 1. This 99 can be rewritten in this form 100 minus 1. 999 can be rewritten in 1000 minus 1. And this 9999 can be rewritten in 10,000 minus 1 form and so on. You can use the same pattern. Now what you are observing is simply just group all the 10 exponents together. So we are grouping 10 exponents together. We are getting one group as 10 plus 10 square plus 10 cube till n terms. Now group all minus ones together. So we are having another group minus times 1 plus 1 plus how many times? N times. Now this sum you know. This is simply your n. Yes, so you will get minus n. So you are getting minus n. Now what about this? This is your GP if you recall. Yes, so this is nothing but your corresponding GP series. So 10, your first term, your second term 10 square, your third term 10 cube up to nth term. Now, how you are going to find out the sum for this? Quite simple. You know the sum of first n terms in your GP. So you require your first term. In this case, first term is 10. So 10. First term times r raised to power n minus 1 divided by r minus 1. So in order to find out r, how you are going to find out r? Quite simple. Just divide a2 by a1 or a3 by a2, any. As in GP you will always get common ratio r, some constant number. So in this case your r is 10. So you are getting 10 raised to power n minus 1 divided by 10 minus 1. Simple. So simplify this denominator. You will get your sum of this sequence up to n terms, which is 7 by 9 times 10 raised to power n minus 1 divided by 9 minus n. Simple. So whenever you see such type of sequences, then you can easily answer about nth term or even the sum. What you have to do is simply form some 9 plus 9 terms like this. Clear? Now moving to next. This example. Suppose a person has 2 parents, 4 grandparents, 8 great grandparents and so on. Then find the numbers of his ancestors during the 10 generations preceding his own. Simple. solution. Here my GP starts with this term 2. So A is going to be 2. Now common ratio, meaning for next generation we are having jump of 2, meaning twice. We are getting the double every time. Each generation we are getting the double of the number. So 2, then 2 times 2 is 4, then 4 times 2 is 8, then again this will continue and you will get the next term as 16, and so on. Now what you want is number of ancestors during the 10 generation. Now you assume n to be 10. So using the sum formula, quite simple. So using the sum formula, Sn is simply a times r raised to power n minus 1 divided by r minus 1. We know the first term a, we know the common ratio r, 2. Now for 10 generations we are getting 2 times 2 minus 1 is 1. So denominator is just 1. Now numerator is twice of 2 raised to power 10 minus 1, which is, on solving, you will get 2046. So the number of ancestors during 10 generations, simply 2046. Simple. I hope the steps are clear. So this is it from this session. Thank you.